Hi, my name is Alec Goulet, and today we are doing the iodine clock reaction for General Chemistry 2 at Duane University. So, what we're looking at with the iodine clock reaction is we have some simple ingredients. We have vitamin C, we have iodine. In this case, I have a povidone iodine solution, and then we have some distilled water, some cornstarch, and hydrogen peroxide. So we're basically going to be making two separate solutions, mixing them together, and see what happens. So in solution A, I have already mixed up two tablets of the 1000 milligram vitamin C in my mortar and pestle. They are right here. I put about 60 mLs of water in there, and it's a little cloudy, so we're going to actually filter that out right now using just a coffee filter. And once that gets filtered out, we're going to be adding some povidone iodine to that here in a minute. For solution B, we're going to add just a little bit of cornstarch, approximately 0.4 grams of cornstarch in about 350 mLs of water. And this solution may need to be heated up, so I'll probably heat that up a little bit, stir it a little bit more, and then filter it out. And then once that's filtered out, solution B will also get approximately 150 mLs of 3% hydrogen peroxide. Alright, so I have heated up the start of solution B already, which is that little bit of cornstarch and about 350 mLs of distilled water. And it is a little cloudy, so what I will do is I will filter it through this coffee filter. And as you can see already, solution A that we have started with the absorbic acid, which is the vitamin C, and the distilled water is starting to clear up nicely. Okay, now that we have filtered down a little bit, I switched containers to have bigger containers. So we still have solution A and solution B. So solution A right now is just the dissolved vitamin C. So now we're going to be adding a little bit of povidone iodine. I have the 10% solution, so I'll be using a little bit less, approximately 12 mLs. What is happening is the iodine, which is colored I2, is reacting with the absorbic acid and becoming iodide, which is I minus, and this solution is colorless. Alright, so now that we have that, we're going to top it off. So we have about 500 milliliters in solution A. This is just distilled water we're adding in. Okay, now for our solution B, we're going to add about 150 mLs of the hydrogen peroxide, which is the 3%. Okay, now that that is complete, we're going to try to add equal concentrations of A and solution B into the same jar. What's happening here is we have two reactions kind of competing with each other, going back and forth. So we have the hydrogen peroxide in the solution B that wants to oxidize that iodide, the I negative, which is colorless, that we created in the solution A, back to colored I2 or iodine. But the absorbic acid, vitamin C, wants to reduce that I2 back to I negative. So from the colored iodine to iodide, which is the I negative. This doesn't really last too long, so hopefully we'll see that here quickly. And then additionally, the absorbic acid is going to be consumed because we added excess hydrogen peroxide in solution B. So that will happen as the I2 begins to accumulate. And then hopefully the I2 complexes with the I negative to form triiodide, which complexes with the starch, and then should leave us with triiodine and starch. We can try to help agitate it a little bit. Now this may not be changing because of the povidone iodine that I'm using. Oh, let's see. Equivalent to 1% available iodine, so I might need more of the povidone iodine than I thought. Call this one over here. Let's see if it needed a lot more of the povidone iodine than I had thought. Try number 3 here. So because even though this is 10% povidone iodine solution, it is only equivalent to 1% available iodine. So that's why we needed to increase instead of decrease the concentration of the povidone iodine in the solution. And as you saw, it was able to change colors back to this darker solution, as we talked about before. Basically the two reactions competing. Cool. After a few minutes, you can see that our second trial is actually now changing too, which goes to show that different concentrations can react at different speeds too. So this was obviously a extremely low concentration of iodine, a little bit higher concentration, and then the most concentration we had here. Well, lo and behold, the first solution did end up changing. I'm not 100% sure on when because I wasn't paying attention. So yeah, it did. So definitely different concentrations can change at different rates.